Hey everyone, I'm going to do a review for Unit 1 for biology. We're going to go over scientific experiments and how to write a hypothesis correctly and identify our variables. We're going to go over how to write a CER and what's expected in them. And then we're also going to go over graphing and all the components that are necessary there. So on the screen recording, I will move quickly to make sure that I can get everything in. So feel free to pause it, rewatch it, whatever you might need. So the first thing you need to make sure you know for the exam is you need to know how to write a problem, and that a problem is going to be a question you want to answer. You do need to be able to write a hypothesis. Your hypothesis should always start with the word if and tell what you are going to change. Continue with then, which is explaining what you think is going to happen. And then finally finishing with a because to tell why you think it is going to happen. You should be able to identify variables such as the independent variable and the dependent variable. You should be able to identify your control group as well as constants, and then be able to write a conclusion. So we did do several examples, and I've got another example here for you. Theodore wanted to test the effectiveness of different types of weed killer. He set up 8 different areas. So here is his question. He wants to know which weed killer is going to be the best. He wants to, we need to write a hypothesis. Again, notice that the hypothesis here is starting with the word if, and then continues with the word then. So if he uses, and then we talk about the different things he's going to do, and then we make a prediction. So my prediction was that Scott's weed killer will kill the most weeds, and then we have to make up some sort of logical answer. So maybe I saw an advertisement. So because I saw that Scott's weed killer is the best, or because a friend told me that Scott's weed killer is the best, we got to come up with some sort of reason for why. The independent variable, which is going to be the thing that the scientist changed, was the type of weed killer. The dependent variable, which is the data that was collected, is the amount of weeds growing. The control group is going to be the area with no weed killer being applied. And then finally, some of the things that have to be kept constant are going to be the area that the weed killer is applied in, same environment, making sure to follow those directions, and so on. So every time we have an experiment, we should be able to pick out these things. So I would suggest you take a moment to pause the video, read through this scenario, see if you can write a problem, see if you can write a hypothesis, identify the independent and dependent variables, identify the control and the constant, and then come back to this video after you have done it yourself and see if you've identified them correctly. And then after that, we're also going to write a claim, evidence, and reasoning. Okay, so the problem that he wants to solve is, will the new breath mint cure the bad breath from eating the Krabby Patties? So I have to write a hypothesis in proper format. If the customers receive a breath mint after eating the Krabby Patties, then it will cure the bad breath from the patties because he used a secret ingredient to cure that bad breath. So that's my reasoning in if, then, because format. Now, we have to identify what he changed. So the independent variable is having the breath mint or not having the breath mint with the secret ingredient. So what he's changing is the type of breath mint that they got. So that's going to be the independent variable, the type of breath mint that they got, either the regular one or the new ingredient one. Now, the dependent variable is the data he collected. So the data that was collected was kind of the report about their bad breath. So whether they had better breath or not, that's going to be the dependent variable for Mr. Krabs. He does have a control group. So he's trying to see if this ingredient works better or not. So his control group is the ones that are receiving that regular breath mint. So that's going to be group B. That is going to be his control. And then we do have some things that are constant. So he is using 50 customers in both of the groups, so that's being kept constant. They are always eating Krabby Patties to check their breath, and they are always reporting this 2 hours. So some of those are the things that are being kept constant. Now, the next thing we want to do is we want to be able to write a CER, a claim, evidence, and reasoning. So we want to make sure that our claim is going to be supported by the evidence that we see here. So we've got some data here about 30 customers reporting 2 hours after their breath in group A versus 10 customers reporting having better breath in group B. Now we want to remember that group B is our control group. So group B is going to get the normal mint, and group A is the group that is getting the new ingredient. Okay, so since I've got more people with the new ingredient having better breath, I am going to answer our question, was that secret ingredient effective? My claim would be that the secret ingredient was effective. And then I'm going to use data to support that answer to my question. Okay, so I'm going to use this data here, and I'm going to put that data as my evidence. And in terms of the reasoning, we really don't have much science to support it yet. But we could say that Mr. Krabs has discovered a new secret ingredient that really works well with getting rid of the bacteria that causes that bad breath. So we can use some of that in our reasoning. We don't have a lot of science yet for this particular one to do reasoning. So I might have to give you some science in here for it, or you could make some logical reasoning up as to that ingredient there. All right, so make sure that you go over how to identify those variables, independent and dependent. Make sure that you go over the constant and the control. Finally, we have graphing. In order to do a graph correctly, you do have to be able to identify the variables. So if we take a look at this particular experiment, you can pause it before I go over it and then try to identify what's going to go on the x variable and what's going to go on the y axis. So our independent variable is what the scientist changes. So Rebecca changed the percentage of salt water that the plants were getting, and the dependent variable, she recorded the number of petals that the plant had. So for this experiment, we need to make sure that we remember that the independent variable is going to be going down on the x-axis, and the dependent variable is going to go on the y-axis. And we need to make sure that we've got both of our axes labeled. So our dependent variable over here should be labeled number of petals, and then we would be labeling those numbers, making sure to go up an even number. You can't go 1 and then 5 and then 8. We want to make sure that we're always going up evenly. So if I go up 1 and then 2, 3, 4, go up by even numbers, or I could go like 5, 10, 15, 20. But we don't want to be going up by uneven numbers. We want to always go up by the same amount. So don't go 5 and then 8 and then 9 and then 15. That would not be a good scale there. Then on our independent variable, we have a couple of different things. We've got percentage of salt, and we've got different percentages. So we're going to have a 0% labeled, we're going to have a 25% labeled, and we're going to have a 50% labeled. And this is actually, we've got numbers on both axes. So we could do a line graph since we've got numbers on both axes, but since we're comparing, usually when we do a comparison, we're going to do a bar graph in order to compare, but I would accept a number graph since we do have numbers on both sides. So you do have to be able to identify those variables. We're going to need a proper title. Our title needs to include both of the variables, our independent variable and dependent variable. So we would say the number of petals each flower has compared to the percentage of salt water received. So we do want to make sure that our title includes both of those variables. So we want to make sure that we've got everything labeled, that everything is even down here. We've put the right item on each of our axes, and that we've got a proper title including everything.